In problem 5, we're asked to make some plots. First, we want to use Chernov's bound to compute an upper bound on the probability that S is greater than or equal to Tn. Well, let's recall what Chernov's bound tells us. Chernov's bound says that the probability that S is greater than or equal to 1 plus alpha times the expected value of S is, at most, e to the expected value of S times alpha over 1 plus alpha, the expected value of S times 1 plus alpha. Keeping in mind that the expected value of S equals n over 2, and noting that we want to get an upper bound on the probability of S greater than or equal to Tn, so setting 1 plus alpha times the expected value of S, or n over 2, to Tn, we find that alpha equals 2t minus 1, and now plugging into our bounds, we have e to the n over 2 times 2t minus 1 over 2t to the n over 2 times 2t, or in other words, e to the nt minus n over 2 over 2t to the Tn. So that's the Chernoff bound on the probability that S is at least Tn. We're asked to graph this in log scale against Stirling's approximation for the probability that S is exactly Tn. Recall from previous work that Stirling's approximation for this probability is the square root of 2 pi nt times 1 minus t, all multiplied after taking that square root by 2 times the tth power of t times the 1 minus tth power of t raised to the negative n. Some complicated formula, but you derived it previously. And all that's left is to plot these two against each other in log scale. Just find some plotting software, plotting app, graphing calculator, put these formulas in, slap a log in front of them, and graph them against each other. We've already done it for you. Here in this graph for n equals 10, the red line is the formula we derived from the Chernoff bound. The blue line is the Stirling approximation. The green line is an even stronger Chernoff bound found in note 19b. It's stronger in the sense that it hugs the blue line closer, but both it and the red line are strictly upper bounds on the blue line, as you can see from the graph. And here's the graph for n equals 20, and here's the graph for n equals 100. And if you like, here's the code which generated these graphs. But you don't really need to see those in the video solutions. In fact, you don't really need to see any of this right now. This was taken very clearly from the written solutions. And why not? No point redoing all that.